All right, good morning, everybody. So at the end of the last class, we had just started to implement some of our own classes. Right, so we got a point2 class, represents a two-dimensional point. We've got a counter class, represents something that can count up, starting from 0 in increments of 1. We've got a stopwatch class that can tell you how much time has passed since some other point in time. Right? Now, if you look at what's inside of, say, the point2 class, there's nothing in it, almost. Right? So that's what our point2 class looks like. It's just a class with two variables in it. Even though there's next to nothing in it, it's still usable. Right? So you can write a main method somewhere else. Right? So this is, we've got the class called OSL_test. Right? And you can go ahead and make a point2 object, and everything works just fine. Right? So you can actually call a constructor on our class, even though the class doesn't have a constructor in it. Right? Can't do much else with it at this point, but at least you can make an object. Right? So in order to make these classes usable, we need to add some extra features to the class. Right? So for example, we want them to perform some sort of computation on the data that they're storing. Right? So for example, for point2, you might want to add a method that returns the x coordinate of the point, or moves the point somewhere else, or does something with the point. Right? So operates on the coordinates of the point. For the stopwatch, you might want to add a method like start that starts the stopwatch, and you might want to add a method like stop that stops the stopwatch. Right? And so you want to pair the data that's in the classes with methods that operate on the data. Right? And so in object-oriented programming, the term encapsulation means the bundling of data and methods that operate on the data into a single unit. So in Java, the class is one mechanism for encapsulation. Right? Okay, so to create our objects, it would be useful to have constructors. Right? So the constructor, this is worth memorizing, by the way. Right? So the purpose of a constructor is to initialize the state of a newly created object. Right? How do you make an object? You call new. What does new do? Well, new calls a constructor. What does the constructor do? It sets the fields of the object. Right? So all constructors should always set the values of all of the non-static fields to appropriate values. Right? So you look in your class, you look at what variables you have, and your constructor should set those variables to some well-defined values. What does your constructor look like? It always has the exact same name as the class. Right? It never returns a value. Right? It can have some parameters, right? So 0 or more. So they look like methods, but they don't return a value. Right? Similarly, you don't have a choice on their name. They must have the same name as the class. Now, our classes don't have any constructors in them. So what happens is that the Java compiler creates one for you. Right? So if your class defines no constructors, Java inserts one for you. Right? So Java inserts the no argument constructor for you, right? The constructor that has no parameters. So the no argument constructor has 0 parameters. Right? If you decide to add a no argument constructor, then the no argument constructor should set the values of the fields to some well-defined state. Right? So this is the constructor that someone's going to use to make a quote-unquote default object. Right? As the programmer of the class, it's up to you to decide what should the state of the default object be. If you don't put one of these into your class, if you have no constructors in your class, you get one for free. So the compiler makes one, and what it does is it takes all of your numeric fields, sets them to 0. Right? So if the field is of int or double, that field gets set to 0. If you have a Boolean field, it gets set to false. If you have any reference type fields, they all get set to null. Right? So they get set to no object. You have to be careful with this one. Because if you rely on the no argument constructor and you have a null field, you can't actually use that field for anything. Right? Null means no object. So you can't call a method with that field. You can't access any of the variables that field might have. You'll have to make an object to assign to that field eventually later on. Right? So be careful about that right there. All right, as soon as you decide you want more than one or more constructors in your class, right, you're going to lose the free no argument constructor. So you have to put one in yourself. So normally, you define a no argument constructor. Right? So what should the no argument constructor for point 2 do? Well, it's up to you. Right? Whatever it does, though, it should set the x and y coordinate of the point to some well-defined values. 0, 0 makes sense in this case. You could pick some other values depending on why you're implementing this class. Right? I'm going to use 0 and 0. How do you do it? Well, you write that. Right? So your constructor name, same name as the class. Right? 2 round brackets because you're declaring a constructor. Right? So it kind of looks like a method. Nothing inside the round brackets. This is the no argument constructor. Right? It has no parameters. Like your class, you can give it an access modifier here. Right? So a public constructor is visible to any class that can see, is visible to everybody as long as the other class can also see point 2. Right? So if point 2 is public, and if the constructor is public, then this constructor is callable by any other class. Right? The constructor should set the x and the y value of the point, of the newly created point, to 0. Right? Now the question is what point is it setting? Is it setting the values to 0? Right? So you want to set the coordinates of the point that was just created by new. And so that point gets a name, or that object gets a name. Right? So that object gets the name called this inside of the class. Right? So if you ever see the word this inside of a constructor or inside of a non-static method, right, that word this means the object that is being initialized. So that's inside the constructor. If it's inside a method, this means the object that was used to call the method. Right? And so the constructors and the methods, they know what object is being used. Right? They get a reference to that object. Right? It's always called this in Java. Right? And you don't declare this in the parameter list here. Right? So there's no parameter whose name is this here. You never include this as one of the parameters of your constructors or methods. Right? So we can put that into our class point 2. So let's do that now. Right? So constructor is public. Its name is point 2. Right? It sets the x coordinate of the point being initialized, to 0. And it sets the y coordinate to 0. Right? Now, inside the class, you have access to these 2 fields everywhere. Right? So even, oddly enough, even before you declare them in Java, which is a bit strange, but that's the way it works. Right? So you have access to x and y by name directly. Right? So you could also write x equals 0 and y equals 0, and that is also fine. Right? And so if you don't write this dot, then the compiler silently inserts this dot for you. Right? Question, yes?
Why do you need to use this dot?
So there will be an example coming up, but there are times when you have to write it. I'm always going to write it, so I will always write this dot in front of the field name, and that's to remind you that, or to be explicit that I'm actually setting a field, right, called x. I'm setting a field called y, right, and I'm not setting something else like I'm not setting, for example, a local variable or something, right, which we didn't declare here anyway, so you wouldn't make that mistake, right? And so some Java programmers will say you should always write this in front of a field access inside of a class, right? You should be explicit that you're accessing a field, right? Other programmers will say it just gets in the way, right? If you don't need it, don't write it, and so they would prefer to write it like that, right? In this course, I don't care what you write, right? I'm always writing this dot in front of it so that you always know I'm accessing a field. Right? But you don't always have to write this dot in front of the name of the field. Right? But you have to remember, right, if you're not writing it, you have to remember that you are setting or accessing the field belonging to some object. Right? So we'll leave it like that for now. What do I want? Where's PowerPoint? Okay. So what happens when you call a constructor and make a new object, right? So when you make a new object, so when you declare a variable p, right, that variable gets declared somewhere in memory. It doesn't matter where, right? So some box gets labeled p. This one happens to have the address 64. The number is not important here, right? You don't actually care, right? What goes into this box? Well, you don't know yet, right? Whatever goes into this box is the result of the right-hand side, right? So what does new do? So p gets created. New allocates memory for a point2 object somewhere in memory. Right? So new takes the point2 class, makes a copy of the class, plunks it down somewhere in memory. Right? So there's your point2 object. Right? Notice what new doesn't do. It doesn't set x or y. So this is exactly like mallocing or allocating a chunk of memory in C. Right? Memory doesn't get initialized, but you do get a chunk of memory, in this case, that can hold a point2 object. Right? What is the thing that fills in x and y? Well, the thing that fills in x and y is the constructor. Right? So the constructor runs, so new calls the constructor. Right? When it calls the constructor, it tells the constructor what is the address of that object. Right? And it gives it the name this. So inside of the constructor, which runs in memory somewhere, right, there is a hidden variable called this. Right? So not hidden, you don't explicitly declare the variable, right? So you get it for free. Right? The value of this gets set to whatever object is being created or initialized. Right? And now the constructor can run. So what does the constructor say? It says this dot x equals 0. Right? So what is this? Well, this is the thing at address 600. Right? Dot x means find the field called x in that object. Right? That gets set to 0. Right? This dot y gets the value 0. So this is the object at address 600. Dot y, look at its field called y, set it to 0. Right? So those two fields get set to 0. After the constructor is done running, new returns the address of the newly created point back to the caller, and in this case, that gets assigned to p. So p gets the address of the newly created object, like that. Right? And so that one little line of code causes a whole sequence of events to happen. And step 3 actually causes another sequence of events to happen, which I will tell you about in a few weeks. Right? But a whole bunch of things happen when you write that one little line of code. And this is one of the reasons why C programmers, when they first saw Java, really didn't like the language. Right? Because that one line of code actually causes a very long sequence of events to happen. Right? To a C programmer, that's hiding a lot of complexity. Right? C programmers like to do everything themselves. They want to know exactly what's happening at each step. Right? Whereas the constructor call here actually causes a bunch of stuff that to happen that the programmer has no real control over. Right? Okay, so what about the other classes? Well, we've got a counter. Remember, so the counter is the thing that counts up from 0 to some integer max value. Right? So what should the no argument constructor do for the counter? So what should the default counter start at? Probably should start at 0. What does the constructor look like? Right? Name of the class, name of the constructor matches the name of the class. Right? Round bracket, no arguments or no parameters inside the round brackets. Right? It's public because we want everybody to be able to use this constructor. What does it do? It sets value to 0. Right? This dot value equals 0, value equals 0. In this particular case, it doesn't matter. Right? One more time, just to enforce what's actually going on. Right? We make a counter variable c, so it gets created somewhere in memory. Right? New runs, so it makes a copy of the counter class, plunks it down somewhere in memory. Right? Memory is not initialized. Right? New now calls the counter constructor, passes in the address of the newly created object to the constructor. So the constructor runs. Right? It has a variable called this. Right? The value of this is just the address of the object that was created. Right? The constructor says this dot value equals 0. Right? So follow the reference to the object, dot value, so the field called value gets the value 0. Right? Constructor finishes running. New now returns the address of the initialized object back to the caller, so C gets the value 550A. Right? What about the stopwatch? So stopwatch, exact same thing, right? We're going to initialize the start time to 0. We're going to initialize the stop time to 0. We're going to say that the watch is not running. What does it look like? Well, start time is 0, stop time is 0, is running is false. Right? If you want another example, so let's cook up another example of some class somewhere. Right? So let's do this circle. So I would like to make a class that represents a circle. Right? So we're doing the mathematical notion of a circle. Right? So every circle has a radius. So we probably want a field that represents the radius. Right? What should its type be? Well, it depends. Right? So if you are implementing a class for circles that have that are on an integer grid, for example, right? You might decide that the radius should be an integer value, right? A lot of drawing programs eventually reach a point where the size of the objects change by integer amounts, right? And so it might make sense to make this an int. Right? If you're doing a mathematical circle, you probably want a real number for the radius, right? So here we'll choose to use a double value for the radius. Right? What else do you need to represent a circle, right? And so the answer is it depends. Right? If you want a circle that you can place anywhere or that knows where it's located on a two-dimensional plane, you probably want the center, the coordinates of the center of the circle. You might want the coordinates of the upper right. So if you imagine drawing a box around the circle, you might want the coordinates of the upper left-hand corner, depending on exactly what it is you're doing with this circle, right? But in this case, you probably want the center. So we need some fields to represent the center location of our two-dimensional circle, right? So again, you could do something like the following. Oops, sorry, private. Like that. Right? And so that those two variables there represent the center chord of the circle. Right? But there are other possible implementations as well. Right? So we just made a point 2 class. Right? So instead of using two double fields for the center point, so alternative implementation. Right? We could use a point 2 object to hold the center point. So private point 2, C in this case. Right? So now our point C will manage the x and y coordinates of the point for us. Right? When we add extra functionality to the point class, right, we get that extra functionality for free if we need to manipulate the center point of our circle. Right? So for example, if we want to move our circle, there might be a method in point that knows how to move a point. And so we can just ask the point object to move itself somewhere else. And that also moves our circle. Right? What a lot of new programmers will do is that they'll throw everything into the class. Right? And so to represent the circle, they'll have a radius. They'll have Cx and Cy that are supposed to represent the center point of the circle. And then they'll throw in another object, in this case C, to also represent the center point of the circle. Right? And so now you have a redundant implementation, right? A redundant representation of the center point, which you normally don't want. Right? It's sometimes useful to have a redundant representation. You probably don't want it in this case. Right? Can you come up with other implementations? Sure, there's lots of other implementations. Right, so what else could you do? Well, if I want to store the center point of the circle, I could store it in an array. So private double 2. Sorry, you can't put the number in Java. Sorry, C-ARR. Right, so now the first element of the array will be the x coordinate. The second element of the array will be the y coordinate. Right, so C-ARR is the x coordinate, right? And CARR1 would be your y coordinate, right? Can you do something else? Sure, you can do more, right? So yet another alternative implementation. Why don't we throw everything into the array? Right? So now private double data. Right, so data 0 is going to be our radius, right? Data 1 will be our x coordinate, right? And data 2 will be your y coordinate, right? What's the best implementation? There is no best implementation. It depends on what you're going to use this class for, right? And we don't really have a good idea of what we're going to use this class for at the moment, right? It's just something we just made up. Right? So it might be handy to have all 3 pieces of information in your circle available as a single array. Right? It may not be. Right? It might be nice, or it's certainly a lot easier if you kept the easier to read if you keep the radius and the center point separate somehow. Right? Should you store the center point as 2 fields? of primitive type? Should you use a point object? Should you use an array? Right? Well, again, it depends, right, on what you're actually trying to do with this class. Right? The only way to know, I guess the only way to know or to be able to choose between different implementations, right, that all comes with experience. Right? So as people who are new to object-oriented programming, you don't really have to worry so much in this course about what is the best representation of the point, the best representation of a circle, right? But you do need to be able to come up with a representation of a circle, right? So the hope is that at some point soon, right, if I was to ask you to implement a class that represents some kind of shape or a circle, you would be able to come up with something that looks like that, right? If I asked you for a rectangle, right, you'd be able to come up with something similar that could represent a rectangle, right? Maybe you want the upper left corner, maybe you want, and the lower right corner, the coordinates of those points, right? That would be sufficient to represent a rectangle, and things like that, right? So you need to be able to come up with representations of relatively simple classes. Choosing between trying to decide what is the best representation, that's a much harder problem. Right? All right. So once you've got your constructors going, so you can add more constructors to your class. We'll add more shortly. Once you're able to construct an object, you probably want to use that object to do something with it, so you want to add methods to your class, right? So in Java, it's unusual, well, is that true? Yeah, it's sort of unusual to create a class that just represents pure data, right? So for example, in C, if you wanted a point to something that represented a point, you would probably just make a structure, right? And to use the point, you would access the members of the structure directly. Right? In Java, the tendency is that you use methods to access the data belonging to the object. Right? And so a non-static method is a method that operates, that uses the fields belonging to one particular object. Right? So for example, if you wanted to, you could add a method that lets the client, the user of the point2 class, set the x and y coordinates of the point. Right? So the method set sets the point coordinates of the point to new x and new y. Right? So given an existing point, right, you would write p.set new x and new y, and that gives you back, that changes the coordinates of the point. Right? How do you change the coordinates of the point? You just change the values of the variable, of the field. Right? So this dot x becomes new x, right? And this dot y becomes new y. Right? This particular version of set returns a point2 reference. Right? In particular, it returns a reference to the point that was just changed. Right? What was the point that was just changed? Well, its name is this inside of the method. Right? So why do you do this? It's because you can write, let me put this into the class. So I'm just going to copy that. I'm going to put that into the class, and I'll show you why you might want to do that. You don't have to, right? You could return nothing in this particular method. But if you return something, it lets you do something somewhat interesting. Okay, so there's our set method. Right? So if you return a reference to the point that was just changed, it lets you do stuff like the following.
Sorry, we can't see.
Oh, what happened? Thanks for letting me know. I did a 220 lecture where I was talking to a screen like this for like 10 minutes, and then finally someone said, hey, we can't see. And I don't know why you can't see, because everything's hooked up. All right, let me try this. That's on. Oh, there it is. Okay. Okay, so there's our set method. I'm going to call set. I'm going to make a point from inside the main method and call set. What is this complaining? Oh, is this complaining? Class body, no, the class body's there. Public static void main string. We're good, right? Oh, this is stupid. If you ever try to copy something from PowerPoint, especially code, you have to watch out because PowerPoint inserts hidden characters that you can't. Oh wait, never mind. In this case, that's not the case. Public, it's here. There we go. Okay. PowerPoint inserts what are called non-breaking spaces into the text. So those are spaces that don't print, but they're not the same as a regular space, and so that confuses many compilers. But anyway, I can make a point object here. So call our constructor, right? And then I can write p.set, so 1, 1. So that changes the point, right? But new point 2. Right? Now the thing is, a set returns a reference to the point that was just changed, right? And so all of this, right? The result of that, that returns the value p in this case, right? So it returns a reference to p, right? And that means you can now call another method. So right, p.set, right? So this means I can now use that and call set again, for example. Right? That doesn't make much sense, right? You might as well just set to 2 and 2. But if there were other methods, right, I can now call other methods after setting the point. So this lets you chain method calls together. Right? So that trick there, by returning a reference to the point that was just used, lets you set up a chain of method calls here. This is useful if you're implementing some sort of mathematical entity, right? So imagine you wanted to move a point and then do something with the coordinates of the point. Right, you could write p.move, moves the point, and then call some other method to do something with the point at that after it's moved. So that's what that's why we're returning point 2 here. Right. Right. All right, so what other methods do you want to provide? So it might be if someone's using a point, they probably want to be able to get the x coordinate of the point. So we need a method that, or I guess set. So this one just lets you set the x coordinate of the point. Right, so rather than, instead of setting both coordinates, maybe just set the x coordinate. Right, so how do you set the x coordinate? Well, you just assign a new value to the field called x. Right, so this x in this case equals new x. Right. Again, we're going to return this so that someone can write, someone can change the x coordinate of the point and then use it to do something else right away. Right. You can set the y coordinate of the point. Right. So I've got a method called y, changes the coordinate of the point to new y. So this dot y equals new y. Right. And so methods like set, that version of x and that version of y, right, they change the state of the object. Any method that changes the state of the object gets the name, is referred to as a mutator method. Right? Mutator meaning mutates or changes the state of the object. Right? Usually mutator methods are called set something. Right? So many Java programmers would say set x and set y. Right? Or set coordinates. Right? I'm lazy, so I just call it x and y. Now, you might have methods that return information about the object without changing the state. Right? So those are called accessor methods. They're often called get. Right? So for example, if someone's using a point, they probably want to know what is the x coordinate of the point. Right? Our field x is private, so they don't have access to it directly. So you have to give them a public method that actually returns the x coordinate. Right? So you can call a method. You can reuse the name of methods inside of a class. So you're allowed to have 2 methods named x. Right? Their parameter lists must be different. So this one has no parameter list. The other version of x took in 1 double. So as far as Java is concerned, these are 2 different methods. Right? So the method x that has no parameters returns the x coordinate of the point. How do you return the x coordinate of the point? Well, just return the value of the variable that stores the x coordinate. Right? So let's return this dot x. Right? For y, it's the exact same thing, right? Return this dot y. All right, so all of those pieces that go into the method, they all have names, right? So the part where you declare the method is called the method header, right? And so it's made up of a bunch of parts. You don't need to memorize that list. It's just easier to look at one as an example, right? So here's our set method, right? The thing that comes first are the access modifiers. There are other modifiers as well. We don't use them in this course. So here, public is the access modifier, means that anybody can use the set method as long as they can also use the point2 class. Right? The next thing that comes is the return type. So if your method returns a value, right, just like in C, you have to say what is the type of value returned. Right? Then comes the method name. Then comes the method parameter list. Right? The names of the parameters, for the parameter list itself, they have to be unique, right? So you can't have X and X here. So the parameter list is just a list of types and names that appear inside the parentheses, right? So exactly the same as C. So one method can't have the names X and so in one method you can't repeat the parameter names, but the parameter names can be repeated across methods. Right, so they don't have to be unique across the class. In Java, there's something called the signature of a method, which C, I don't think C calls it the signature. Right? So the signature turns out to be important in Java because it determines whether or not you can include a method in a class, and it also determines which version of the method is called. Right? So the signature consists of the name and the types in the parameter list in the order that they're declared. Right? The names of the parameters don't matter. Right? So the signature of set is set double double. Right? So if you have so in the string class, you've got a method 2 uppercase that returns a string. Right? The signature of 2 uppercase is just 2 uppercase. Right? There's a method called getCars that takes in an int, an array of car, and an int. Right? Its signature is getCars. Int, array of car, int. Right? So just the name of just the types of the parameters and the name of the method. Right? So inside of a class, your signatures must be unique. Right? So if I wanted to, we could put in another method called set, right? That changes just one of the 2 coordinates. Right? So we can put in the method set double x that changes the x coordinate of the method of the point. Right? And I guess it sets the y coordinate to 0 in this particular case. Right? So that would be fine because our current version of set takes in 2 doubles. Right? So the signatures are unique. You probably don't want to do this because as soon as you do this, you probably want to do the same thing with y. Right? So in other words, provide a method of version of set that changes the y coordinate to y and sets the x coordinate to 0. But you can't have both of these methods in the same class. Right? They have the same signature. Right? Their name is set, their parameter type is double. Right? So you're not allowed to add both versions of this method to the same class. Right? Even though the parameter name changes, the parameter name doesn't affect whether or not, or has no effect on whether or not you can include a method in the class. Right? So in languages that let this sort of thing happen, right? So C, you can't have 2 functions with the same name. Right? But many languages allow you to have functions or methods with the same name. Right? They have to differ in some way. Right? These languages say that the methods are overloaded. Right? Same name, different methods. Right? So you might include a method called distance2 that computes the distance to another point. Right? Because that's also a useful geometric operation. Right? So you might provide a version of a method of distance2 that tells you how far it is to another point, where the point is given as a point2 object. Right? You might provide the similar version of the method that computes the distance to another point, where the other point is provided as 2 doubles, right? Or as 2 floats. Right? So all 3 versions of these methods can exist in the class at the same time. Right? The version of the method that gets called is the one that most closely matches the types of the arguments that are passed. Right? So if someone writes q.distance2 some point2 object, then it's the third version of the method that gets called. Right? If someone writes q.distance2 1.0 2.0, it's the second version that gets called. Right? And if someone writes q.distance2 1f 2f, it's the first version of the method that gets called. Right? So the compiler tries to match up the arguments to the version of the method that most closely matches the types of the arguments. Right? And so that's three examples of, the method distance2, these are all examples of overloaded methods. There's something I forgot to tell you because you're C programmers. All right, so in C, right, the temptation is to write the following. Right? So here in Java, if I want to set the coordinates of the point, right, I use a variable corresponding to the point whose coordinates I want to change, and then I call the method passing in the new coordinates. Right? As a C programmer, right, you probably want to write the following: set P 1 1, like that. Right? So as C programmers, you're used to writing a function, right? The function takes in all of the information it needs, right? So it takes in a point, right? And it takes in the coordinates to set the point, to set the values of the coordinates to, right? And that's what you're used to writing, right? So what you should try to get used to when you're using an object-oriented programming language is that one of your parameters, in this case P, right, is actually used to call the method instead, right? So here, let me get rid of this nonsense here. Right? So in Java, right, your argument P becomes the thing that you use to call the method. Right? And so you want to write in Java p.set 1 1, right? Ask P to change its coordinates to 1 1. Right? In C, you write a function that changes the coordinates of P to 1 1. Right? Now, if you're really determined, right, to stick with the C way of things, you can still do this. Right? So if you really want a version of set that looks like that, you just make it static. Right? So public static, I guess we'll return a point2 object. Well, let me return void. So set point2 P double new x and new y. Right? So remember, static methods don't use an object to call the method. Right? You use the name of the class. I'm inside the class, so I don't need to write point2. Right? Inside the method, what does it look like? Right? Well, I'm inside the class point2, right? So I have access to whatever the private fields are of that object P. Right? Remember, X is private. That means inside the class. That means X is only visible inside the class itself. Right? I'm inside the point2 class, so I'm allowed to write P.x in this case. Right? P is a point2 object. I'm in the point2 class. I can see everything that's in that object. Right? So here, I can write P.x equals new x. Right? And P.y equals new y. Right? And so if you really want to provide the function version of the method, you can. Right? You just make it a static method. Right? What you want to avoid, though, is making all of your methods look like this. Right? So if you're new to Java and you're a C programmer, right, you want to do things in the object-oriented way. Right? So you want to get used to writing that. Right? As opposed to refusing to learn any of the object-oriented stuff and writing all of your methods like that. Right? If all of your methods look like that, whoever's reading your code knows you're a C programmer. Right? That's the object-oriented way of doing things. Right? Ask an object to do something. Right? That's the procedural programming, the procedural programming sort of way of doing things. Right? Write a function that changes or uses its arguments or does something with its arguments. However, Java does make it possible to provide both versions of these methods. Okay. So in Java, if you have a method, it has to return something, right? If it returns nothing, then you have to say void, just like in C, right? So our method named x returns a double value, right? The x coordinate of the point. Right? Very quickly, if you use the Java language for any amount of time, you very quickly realize that there are some methods that you can always call if you have a reference. Right? And so in Java, the way that Java implements classes is that every class that you create is what's called a subclass or a child class of this thing called big O object. Right? So remember I told you that in Java, reference types, they all have more than one type. Right? So for example, an array list is also a list. Right? So it's also true that if you have an object like point2, a class like point2, point2 is also a big O object. Right? What that means is that in Java, every reference can be used to call any of the methods that are defined in big O object. Right? So big O object defines a bunch of methods, but there's three that we care about. Right? There's a toString method, there's an equals method, and there's a hash code method. Right? ToString generates the string representation of an object. Right? Equals tests whether or not one object is equal to another object. Hash code is used when you want to use one of the hash containers. So if you're using a hash set or a hash map, the hash set or hash map is using this hash code method to do something. Right? So toString should return a textual representation of your object. Right? So for example, if I have the point -1 and 1.5, I would like to print the point. Right? That sounds like it would be useful to do. When I print the point, I would like to see something that looks like that. Right? So round bracket, x coordinate, comma, space, y coordinate, end bracket. Right? How do you do that? Just define toString. Right? So we create a toString method. Right? So its name is toString. toString never has any arguments. It always returns a string. It's always public. Right? This thing here, this @override, is optional. Right? You don't have to put that in. Right? If you put it in, though, the compiler will check. Right? Is the method that you're defining, does it actually replace or override one of the methods that you got from big O object? Right? So remember, all big O objects have a toString method. Right? If you define your own toString method in your class, you are said to be overriding or replacing the version of toString that we got from big O object. Right? So now when I call toString using a point, right, I get this version of toString rather than the big O object version of toString. You might wonder, what does the big O object version of toString do? Right? So I can print out P. Well, let me do P toString to be explicit. Right? So notice there, I can call toString using my reference P, and the Eclipse is not complaining. Right? I haven't defined toString yet. I get one because point2 is also a big O object. Right? So if I call toString using P, I get the big O object version of toString. What's this going to do? Where's this going to print? Sure. Sure. There it is. Right? So what you get is that, right, which is just a bunch of gibberish. Right? It says lect.point2, so the name of the class, then an @ and then some combination of numbers and letters. Right? That combination of numbers and letters, it turns out that is related to the actual memory address of the object. It doesn't help you at all. Right? In Java, the memory address doesn't, the programmer can't use the memory address for anything useful. So that's the version of toString that you get from big O object. Right? Not particularly informative. Right? If I want a nice version of toString, I simply redefine toString. Right? So public string, toString. Right? So the string that I want to return starts with the opening round bracket. and then it's followed by the x-coordinate of the point. Right? Followed by a comma and a space. Right? Followed by the y-coordinate of the point, followed by the closing round bracket. Right? So I've just redefined the version of toString that we got from big O object. Right? If you put in the @override tag, right, Eclipse does nothing in this particular case, right? So it doesn't indicate anything. It doesn't look like this has done anything for us, right? So what that tag does is it forces the compiler to test or to check, is there actually something called toString that is public and returns a string inside the object class, right? And in this case, the answer is yes. If you change something about this, so instead of writing to big S string, I write to little s string, now you get an error, right? It says the method little toString of type .2 must override or implement a supertype method. It's telling you there is no method called little toString in the class object, right? So you're not actually overriding the method, you're creating a new method. And that is flagged as an error, right? If you get rid of the @override, the compiler doesn't check, right? And it thinks, well, you're just adding a new method called toString, right? If you want to replace an existing method, right, the method signature must match the one that you're replacing. If you put in @override in front of your method, the compiler will test whether or not you've got the correct signature. I think it also tests the return type. So it'll test everything for you, right? So it's there for your safety. It's not actually required. All right, so I guess I will stop. Oh, wait, we can now let run the program, and then I'll stop. So now when you run the program, right, you get out the nice printed version of the point instead of the not so useful version that we got from big O object. All right, so if you have a quiz this afternoon, I will see you in the lab this afternoon. Otherwise, I will see you on Wednesday.